Yes, thank you very much, Vinayak. Um, I'm happy to share a few things about the M.Tech program in EV technology. Little more about what is the course all about, and little kind of more description about each and every aspects through which we can basically learn so many things in this curriculum as well as in the syllabus. So, welcome once again. This is going to be a kind of small introduction first to the EV vehicles, and then thereafter we'll talk about what is SDV architecture, the involvement of AI, and then what are the precautions that we need to take to uh, into the automotive cybersecurity. And after that, we'll be discussing about the curriculum that we have drafted in order to ensure that each and every component of EV vehicles, the technology, as well as the entire infrastructure unit that is required to build or the functioning of the EV vehicle based on the software modules and as well as the security part of the entire system. Moving towards the different types of EV vehicles that we have in the market. Right now, everyone is very much aware that EV, because of low emissions, emissions in the sense like the electric being generated in the grid that is being passed to an EV vehicle, that generation of the electrical, but not the emissions that comes from the vehicle is harming the environment. So there are basically four different types of vehicle right now present in the market. The first one is the battery electric vehicle. And the second one is the hybrid electric vehicle. The third is the plug-in hybrid electric vehicle. And the fourth one is fuel cell electric vehicle. So we'll just see what are they. Before that, all of us basically know the most popular vehicle, the EV vehicle in the market is Tesla. And now it is in the news, and everyone know very much that something which is cracking or breaking the market is here BYD. So BYD is nothing but Build Your Dreams, which is a China company. Started in 1995 into manufacturing small batteries, but um, launched their first F3 vehicle, EV vehicle in 2005, 2003, and thereafter, now they are very much in the market competing with Tesla. So we'll discuss a little kind of comparison between these two EV technologies, which is in the market as well, at the in between the discussions. Thanks. Moving forward, the basic battery electric vehicle uh, consists of the components which are your battery, your control module, the electric motor, and the inverter. So the functioning, as you can see, that we are very much get rid of so many components from the car, um, which makes it easy for us to even build a car in a very less time. That is the first advantage. Talking about the functioning, as you can see, that a battery need to be charged, and we have a control module that is for the acceleration and the acceleration. So when we do an acceleration, the inverter help us to pass the electricity to the motor, and the motor functions. And as soon as we apply a brake, it regenerates the electric energy back, and your battery can be recharged. So regenerative also will makes the battery to be charged. So uh, and if we talk about the features of this normal battery electric vehicle, uh, there is no emission. We don't depend upon any oil. Very cost effective, low maintenance, reduced noise pollutions, and very easy to drive as well. Talking about some of the problems which could encounter from this is like the recharging point. So the scarcity is definitely because it is newly into the market. very much when we talk about India market. Obviously, the charging point need to be set up. So that is one of the concern, and it is being installed at many places, and it is happening also. The driving range is less. Yeah, it goes up to say 300, uh, 300 to 400 kilometer per charge. That is the maximum that we know. And the speed also, it has a limitation over the speed as well. But the pickup, when we talk about a petrol engine or a diesel engine, when we talk about initial pickup within seconds, we could see that electric vehicle are much better in terms of milliseconds to move in a very simple, in a very small milliseconds. And the another disadvantage is definitely it takes a longer recharge time, and the price is also very high. So these are a vague problem that we are facing right now. No, but research is being done, and our our motto is to actually find out all the research problems through which we can overcome certain problems that we are encountering to this electric vehicles. The second type of vehicle is basically is a hybrid electric vehicle, so which definitely have both the electric, you have the battery as well as you have a fuel tank. So we are making use of both in a serial mode or in a parallel mode or in a combined mode. So we have options to run the vehicle in three different modes. So the basic component for this electric hybrid electric vehicle. It consists of your IC engine. You have a power electronics, which maintains all the electronic signals from to all the different components of the vehicle. You have a battery pack with a controller as well as the inverter, which is required to convert your AC to DC or DC to AC, and then you have the fuel tank also. So once you drain with your electric power, you can go for a fuel tank, or you can have both together being used, so that the efficiency could be increased. So just let us talk about the features. Very environmentally friendly is a regenerative braking system is there. That means whenever uh, you apply the brake, it regenerates the energy in the form of charge, which can be stored into your battery. And there's an assistance from electric motor. It is basically having a smaller ranges compared to the other vehicles, and then it has got a higher resale value because it consists of both the components, have the fuel tank and as well as the electric part. The problems that you could encounter with the hybrid electric vehicle is less power because it's a hybrid mode, so it's going to be very expensive, and a poor handling could happen actually, and removing battery even for the normal, the first version, I mean, where you don't have this hybrid part, the battery replacement is definitely is the actual cost of the vehicle, so replacement will be definitely a cost, very costly. So let us elaborate little more about this hybrid vehicle. So it has got two parts. One is the internal combustion engine, and the second part is your electric motor. So in total, there are five components as you can see in the diagram. So you have an engine, a transmission gearbox, the generator motor, and a power control module which has got the inverter as well as the converter. And on the right side, you can see a high volt battery and a low voltage, that is a 12-volt battery. So the high volt battery is basically where you store the charges, and the low and this 12-volt battery is for supplying the electricity to the accessory smaller part of your car, not to the motor actually. Uh, so if we divide this hybrid electric vehicle, uh, we can run the hybrid electric vehicle through three different methods. One is a series hybrid method, the second is the parallel hybrid, and the third is serial parallel. That is the combination of these two. So let us talk one by one. So the basic concept of this hybrid electric vehicle is you have an internal combustion engine, which usually make use of the is a kind of your diesel or gasoline engine, smaller. And what it does, it through making use of the fuel, it generates the power. And with that power, the motor, electric motor, will be running. And the electricity, which is basically is produced from the electric motor, uh, provides the power, and it is being known as the permanent magnet synchronous motor, AC motor. And it provides the instant torque for the smooth acceleration, and it also assists the engine. The 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 fuel, which so the internal combustion engine has stated it does the role of generating the power from the fuel, and the electric motor generates the power from the battery. So here we have a generator. The job of this generator is basically is a electric motor functions. It functions as a generator. So the charges is stored in, as I mentioned, is for the high volt battery, and it is a three phase, and it can store the charges up to say your 100 to 600 volt. And a transmission is a process by which you the power which is generated either from the fuel or the electrical motor, it get passed to uh, your final drive actually. Okay, so it's a combined power which is from the internal combustion engine and the electric motor. And as we have seen in the diagram, like a power control, the which work or act as an inverter, or a converter. It's a three phase, and it converts the AC electricity from the generator to DC, and that is for the battery. And inverts the DC electricity from the HV batteries, that is your storage battery, to AC for the motor. So if you look at this, the power control module, it actively manages the power flow, and and it controls both your engine as well as your motor together. And as I stated already, that 12 volt auxiliary batteries for lights, radios, in starting of your, and it is not at all involved in the main hybrid powertrain. And as mentioned, the high voltage battery is the storage unit for, and it is typically of Leon or NIMH battery package. So a hybrid vehicle, which is a series or a parallel or a series parallel, uh, generates or give your power to a vehicle to move in a different way. So if you see the series, it involves the engine to supply the power to the motor, and then from motor it is being supplied to the transmission unit, that is to the gearbox to drive the vehicle. And when we talk about the parallel, the engine and motor together. So the engine and motor together supplies its power to the transmission unit, so as the vehicle to move or drive. And the last one, which is a series parallel, uh, you have the engine and motor together providing the power, but it is in the split way. So if you want to switch from one mode to another mode, from engine to motor or to motor to engine, it is possible in the series parallel hybrid vehicle. So looking little more in depth of what is a series hybrid vehicle, you can see engine uh, from engine, you have the power being moving to your generator. The generator generates the power. So the generator produces a three-phase high AC voltage, and that is being passed to your power control module, and from there it goes to your high voltage battery. And here the you have the storage of your charges in the battery. both the batteries, auxiliary as well as HV batteries. Now from so the HV battery, once you have the charges in the HV battery, from HV battery, uh, the DC, it goes to your power control unit. So the DC being converted into a three-phase AC, and from there it goes to your motor. So once it reaches the motor, it goes to your transmission unit, and from the transmission unit, it goes to the drive, and your vehicle start moving. So this is a simple fundamental method by which a series hybrid vehicle works. So engine to generator, generator to power control, then to battery, battery to power controller, because you have inverter and converter in the power control module. And then from there it goes to motor, and from motor to transmission unit, and finally it drives. So it's a series, as you can see, it's a series of transmission of power from engine to your transmission unit. Uh, so, and then, yeah. So, since due to the sequential nature of the power flow, this type of hybrid system is referred to as a series hybrid system. Now, talking about the next one, which is known as a parallel hybrid vehicle. So, it has got both the internal combustion engine, it makes use of the engine, and the motor work, electric motor, and it works independently to make your vehicle move, propel the vehicle. So here in this diagram, you can see both the engine, you can see the engine as well as the power which is being generated from the battery through the power control unit. It comes to the motor generator, and both together independently goes to your transmission unit parallel. So you can see a parallel movement of the energy, which is which is getting passed through a transmission unit gearbox, and through which the vehicle will propel. Now, since so it has got uh, three components. One is the combustion mode. So the engine, the ICE, provides the primary propulsion, as you can see, and then you can see the electric mode. That is, the vehicle operates solely on the electric power. This unit, this part, okay, this is possible, and you can see the combined mode also in parallel hybrid vehicle, wherein both the IC engine as well as the battery, it comes together so as to drive the vehicle. So the engine basically it typically serves as a primary means of propulsion, and with the electric motor, it acts as a backup. So once you don't have the fuel, then we make use of the battery to run the vehicle. Okay, now why it is known as parallel? I think it is clear to everyone that we are making use of both the engine as well as the motor. The motor make use of the battery, and the engine make use of the fuel, and it together transmits its power to the transmission unit, and the final drive will happen. So therefore, only it is known as parallel hybrid vehicle. Now, talking about the serial parallel hybrid vehicle, here the engine has the capacity to transfer the output power, and that is directly to the transmission through the power split. So what is this power split? So whatever power that you are getting from one, that is from engine, and whatever power that you are getting from the battery, that is high voltage. So these two combination, they are transmitted in a ratio, in a split, so as to make it more efficient. You know? So it is not like you are going to use engine full time. You are not going to, or it is like motor is being getting used full time. Actually, we try to make it energy efficient, and try to see that if you could utilize the battery more compared to engine, so as to make it environment friendly also. So the mechanical path is like it can directly connect to the engine, to the transmission. Electric path is it transfers the power from the electric motor to the transmission. And during the operation, what it happens is dynamically. So here comes the concept of and concepts of embedding your codes or the software to the power split unit, so as it could dynamically adjust the power. So in the series mode, as I already stated, like energy flow from engine, generator, battery, and motor to the transmission. In parallel mode, we have the electric mode, the combustion mode, as I already stated, and the combined mode of these two. And so this is the combined mode. Okay. So this dynamic distribution, which maximize the fuel efficiency and performance when compared to both the first one which we talked about is like series hybrid and the parallel hybrid system. So talking about a comparative study between these three, in series mode, it is being applied only in a uh, series mode, that is from IC engine. It generates the power, passes through the motor and then to the transmission unit. And when we talk about the efficiency into the environment is like 50%, you can say it is 50-50%. Talking about the parallel, you can see most of the time engine is being used, and once the consumptions of the fuel is over, it would make use of this motor. To make it a little more efficient, what it is being done is both the series and parallel are combined. And once this is being combined, you can see the efficiency of serial parallel hybrid vehicles are much better, which gives an efficiency of say 55% more compared to the other methods like series and parallel individually. We talk about the next vehicle, which is plug-in hybrid electric vehicle. In this, we have the power electronics, different components, like we have the power electronics, electric motor, we have the IC engines, we have fuel tank, battery, and we have the charger also. Okay, so herein we are plugging in, we are charging up our unit with level 1, level 2, and level 3. So as the level increases, it requires more voltage to charge the vehicles. Oh, that depends upon your battery capacity, that depends upon the range that is required actually. So the features of this plug-in hybrid electric vehicle is zero emission, is a fuel efficient in traffic. They are very smooth, quiet, and reduce, yeah, obviously bills, and it's a tax efficient also. And they're quite expensive, complex to maintain. Battery life is a concern. Obviously, battery life for any EV vehicle is a concern actually, and resale value here is little uncertain. And and the various part I've already talked. And so these are some of the problems that you can encounter with the plug-in hybrid electric vehicles. Moving on to the last one, which is known as a fuel cell electric vehicle, wherein we make use of a fuel cell that is chemical energy. So we want the chemical energy to be converted into an electric form. So we have the battery pack. Yes, as you can see in the diagram, we have the battery pack, we have the electric motor, but at the same time, we have a fuel cell stack, which stores which converts the chemical. Here we have the hydrogen fuel getting converted into the electricity, which is being transmitted to your electric motor through your power electronic controller, and that way it drives the car. Uh, so it's simple, like hydrogen plus the oxygen gives you the electricity, and which is being used by the electric motor and drives the unit. But yeah, it is quite. We can say it is renewable and readily available. Uh, Hydrogen support zero carbon, so zero emission, highly efficient, and fast charging time. But the problems are like extraction of the hydrogen. So to get the hydrogen is a tedious process, and then your fuel cell basically need quite big investments. The overall cost will definitely increase, and the major concern is like storage and transportation of this hydrogen, which is very complex. So there are four different types I I explained, which is very much there in the market. You will find all the variants with different motor vehicles. Uh, but when we talk about research of an electric vehicle, it's just not about the vehicle, it's about each and every component of the vehicle. To make your vehicle very, very efficient, all the components that you have seen so far with this vehicle need to be researched. You have to do research on that to increase the efficiency with zero emissions. Okay, so it also depends upon some motors. So motors are of different types, and these motors basically uh, also play an important role in finding out the efficiency of your uh, mileage, efficiency of your emissions, efficiency of the drive, the transmissions that is happening in all the tires. So this plays an important role. So it's just one component like that. Each and every component, whatever the hardware units or the electronic units, at the same time the software unit, which is software defined, when we'll come to that also, software unit. So each plays an important role. So if somebody asks me like uh, is it like optimizations can be done at a hardware level, or is it possible to do an optimization at a software level also? Yes, of course, because see, when we talk about software and computer science, when we talk about writing an algorithm, definitely we are writing it for most of the time we are writing it for the hardware unit. So if we can write the algorithm in a very optimized way, making use of each component based on the attributes in such a way that based on the requirements. Say, for example, if you want a cost-effective vehicle, electric vehicle, in terms of say mileage, that is a different thing. In terms of say the distance, it can pass, it can it can move at one stretch with one charge. So that is different. And if you say that to make it efficient in terms of um, battery energy saving in the battery or battery management system, so that is a different aim. So you may have different aims, and based on this different aims, you will have a different research problem statement. So all this could be addressed definitely through your software part also, and software plays an important role just because of the reason these algorithms that you write, you can optimize this based on the desired output. Okay, so the combinations matters. It's not like that if I want to move from one place to another place, there are so many things involved. So, for example, if I want to move from point A to point B, so I suppose I have five paths to reach from A to B. Okay, so definitely these different paths will have different kilometers. So it may be 10, 20, 30, 40, and 50 kilometers, say for example. Okay, but the traffic at 50 may be less, the traffic at 10 may be very high. So it is dynamic situation. So there are so many external factors other than the internal or other than the physical factors, physical component factor. There are so many external factors that also affects your desired state or the outputs. So therein is the requirement of your software defined unit in the vehicle. So let us elaborate little more about the various topics that we do have in our M.Tech program, which is started newly this year, and you will experience all this big part also into that. I will show you the curriculum as well as the content of the syllabus to everyone. So the first part is basically is the software defined vehicle, as I was mentioning that the architecture. So let me just show you us that architecture as well. I hope this architecture is visible to everyone. So this is a very abstract architecture, as you can see. We call it, say, AutoSAR, which is also known as what Automotive Open System Architecture, which is basically open to all software, all sort of vehicles. And the research is, you know, well, so this is not kind of a defined architecture, or I'll say that this is not the layers which is very much defined and you have to follow it as it is. You can make your own architecture. It is an open system architecture. So you can build your own architecture keeping multiple components in one single layer, and based on that you can reach to your application layer based on the requirements. So any vehicle definitely have the hardware unit at the base level. Say for example, here, yes, you can see the microcontroller unit. So whatever program that you write for the microcontroller unit, so an abstract layer, for you can see there are three abstract layers which drives the complexity, which is a complex drivers, which drives the required features for all the electronic circuit units, or your microcontroller, or the services that you want to provide to a runtime environment, to the application layer where the user just click on a particular one button and it happens. I mean, it get executed. So for example, if I just press on a button, it moves and it get adjusted based on our requirement. So this all happens just because of you are able to write a program, and this program is optimized a program, and based on an instant requirement it responds. Okay, so this is one simple architecture issue. You can build your own architecture because there are so many stack layers you can put across. When we talk about an autonomous vehicle on a road, it makes of an architecture which not only need to take care about the environment wherein it is about to move, but it also need to understand the roadside units. It need to know the roads. It need to know when to halt. It need to read the signals from the roadside unit and or the infrastructure which is built for the vehicle. And it also need to make use of multiple layers in the software, which locate its position from time to time. Okay, so this is something very interesting, which people can work on. And so let us just go back to our presentation. Okay, so diving into the software defined vehicle, what we are very much interested is like how to monitor the speed, how to make sure that the battery charge is optimized. I mean, you ensure that battery is not draining too much very fast. You can store it, you can utilize it constantly, and also could understand the driving conditions. Okay, so everything matters actually. So when you're moving from point A to B, as I was mentioning, but it's not just about the distance actually, it's about the traffic, the time taken, it's about the comfort, it's about the safety, it's about the cost involved that you pay to move from A to B. It's about so many attributes and its value. So when there are so many attributes, obviously it is upon our desire. Say for example, if I want have a meeting, I want to move from A to B at a particular time, I want to reach to that particular point. So here the concern is the time. The it's not about the cost. So you will try to take a longer route. Not do don't go You won't go through the traffic actually. So fuel consumption may be same when you are in the traffic, or you go through the longer route. But there the time is important actually, where you don't have any vehicle and you can move fast and reach maybe say 10 minutes early or 20 minutes early from the and avoid this traffic. So there are multiple factors. So when we talk about an architecture, the architecture that you make for a vehicle, uh, which is now, as you can understand, that all the autonomous vehicles is completely all the hardware units. So they works based on your software commands, and that is something really really very amazing thing in the market, and that is what everyone is trying for. This is a simple pictorial representation of what you have altogether in a vehicle, and how you can build your stack. If that means your architecture layer by layer, to understand that what comes when. I mean, like what sit on top of the next layer. So, for example, you have an autonomous vehicle, and if it is at a halt state, and if it has to move, first it need to understand it need to create the map uh, around around the vehicle. So, as you open a Google Map, say for example, you move from one point to another point. So you could see the entire map. You could see all the routes. Okay, so the first situation is the mapping. So that's one layer actually. So as soon as you start moving, and you have located your destination, then it has to find out the shortest route. So the another challenge is like dynamically find out those shortest path actually. So we need to ensure writing the shortest path algorithms to ensure that you will reach there on time. So everyone know about how this uh, Google Map basically, yeah, it works actually. And these layers that you built, I mean, every point of time when you want to make a move or when you want to make a turn, you need to read the roadside units to understand it's a green signal you can move, it's a red signal you have to stop. At that point, those are the key layers that you have to build on top of one another so as to reach to the destination. So obviously, yeah, EV vehicles, EV technology, giving a better contribution in terms of one thing, that you don't have so many hard units. I'm not saying hard electronic units, but hard units, mechanical units in your system right now. You have simple battery, you have some motor control unit, you have an inverter, and that's it actually. So you basically don't need to worry about so many hardware unit to get into a complex situation. So it make so to have a autonomous vehicle with a EV system, it's quite easy and it's quite better actually. Now, while so there are two distributed architecture we generally use. One is the distributed architecture, and the centralized method to control the entire system, uh, entire movement of a vehicle. But when we talk about the future, it's about a zone architecture, and a zone architecture is something which is quite scalable, reusable. I mean, you can reuse it, and it's efficient to develop. As you can see, it's safe and redundant network, and quite a scalable platform. So only few items we need to bother in a vehicle, rather than bothering about each and every mechanical hardware unit in this system. So that is all about like your software defined vehicle, and I'll elaborate little more at the end with the syllabus as well. Now moving on to the development of the automotive software for the automotive system. Here we have so many, uh, as I was mentioning about AutoStar. Okay, and we all of us know that's Simulink and this MATLAB, and there are like functional safeties, which are the key concepts for developing the software for the autonomous vehicle. And many who were little aware about the different units in terms of say senses or say the networks. So there are many networks like CAN or LIN. They are the protocols, the networks, interconnected network or a that's a area network, which basically we basically use to define our protocol to either make our system fast or in some selling is little slow comparatively. Okay, so these are the these are the hardware units in the embedded form with your in your system, which assist a driver. We call it say ADAS, and obviously the for these systems to work, we have this RTOS, which is an real-time operating systems. So an embedded system in a vehicle with various components need to get connected to the software unit for its function. AI, as we all know that whatever the data which is in the form of raw, we call it raw data that you can percept for using your sensors, different sensors in your vehicle, or it is quite easy for us now to segregate these data. Okay, and also to apply different algorithms onto this data to figure out or do some prediction which could help us for a long battery life, for the life of the vehicle, and life of each components of the vehicle as well. Now, I won't say it's quite easy. I said easy in the sense that we know what are the algorithms which can help us to do the calculation, but at the same time, since the complexity increases in terms of computing, and computing which is obviously it's not a small data, it's a time series data that you are getting continuously from the sensor uh, which is percepting information in the form of video or image or audio or text, whatever it is, or and this huge data, which is a time series data, dynamic data, which comes to you continuously, need to be processed very fast, and need to get a response to the driver so that he could take a decision. So to do that, for the for the instant response for some of the for some of the actions, we make use of the edge computing, which is between your cloud and your say the driver, and these are smaller unit which does the calculations for the with a lesser number of data and give an instant information back to the driver to make the decisions. But for the critical uh, decisions when you are driving a car, obviously it need to reach to the cloud, get executed using the algorithms, and it need to come back actually. So all this fusion, and it is not just one single data. I said it's a large, huge data, and the combination of different data like text, audio, video, images need to be fused together to be utilized by the algorithms. Okay, so when I say AI, it's about uh, ensuring that you are writing in very optimized algorithm, which can make use of the uh, raw data, pre-process it, train it, and ensure that when there comes a new data, it could predict the things as we as a human being predicts. So, in short, I would like to say that we are in the phase, we are running towards the AGI, or known as artificial general intelligence. So far, we started from statistics. We moved to the next point, which is known as weak intelligence, weak artificial intelligence, uh, and a weak artificial intelligence or something is which is based on input. So you have an input, and it is for a specific task. You do the task, you predict something, you got the output, is done. But now it is not all about that. We are moving towards artificial general intelligence. Now we are blessed that with our research, with our movement from statistics to machine learning, from machine learning to deep learning, and from deep learning to the next level, which is known as generative AI, which consists of dealing with your text, image, your audio, your video, and the most important thing is the synthetic data. So we are able to generate content like a human being. So if we are able to do that, it means that for the automotive industry, like for EV, the vehicles, we are able to connect with the vehicle. So people getting connect with the vehicle is getting connected to another vehicle to vehicle, and at the same time vehicle has to be connected to the infrastructure. Okay, so this is all quite possible and quite easy when we talk about a module to into which we are going to put the software defined softwares, and ensure that with a minimum complexity on an electric vehicle with lesser number of mechanical components, it's quite easy for us to figure out the things. One important point is while talking about battery, I mean, getting it charged from an external unit or resources. Uh, we have mentioned I've mentioned about the renewable charges also. The one I've mentioned is like hydrogen. Uh, at the same time, solar energy, wind energy. There's so many different forms of energy. But how to make it to how we can make it so optimized? Say, for example, solar energy, that the electric vehicle battery could be charged, I mean, instantly or within a very less time compared to what the charges that you obtain from the electric grid. If that is possible, then renewable energy is the best source of energy with 0% emission. Because see, when you are plugging into a electric grid, obviously that electricity is being generated through various different methods, which is through the emissions also. But yeah, it is true that the electric vehicle is not giving up this emissions. Now, the most important and the last thing is about the security. Like anything that you develop, which definitely is a hardware unit, the failure could happen to a hardware unit because of so many reasons. It may be because of the temperature, humidity, and it is because of the lifespan of that electronic units. At the same time, so when we talk about the software also, it's about the bugs, the errors which could happen at any point of time. So a clean software, we say, or agile model that you build for the architecture for a vehicle, it need to attend one more important thing, which is the security aspects. It's not just about the bug, it's about the security aspect. So anybody could enter into your vehicle, anybody could damage your vehicle, control your vehicle, and make accidents. Anything can happen. So uh, once your vehicle is connected to the internet, once your vehicle is connected to the cloud, the threat is always there. Okay, even though we build up anything, the most important thing that we need to address at first point of time, whatever we build through AI, the most important thing is the security aspects. So if we could do that, then definitely things will be quite positive. Now, two more slides, and after that, I'll show you the syllabus, the curriculum that we offer, and you will find so many interesting things to learn actually, and everything is very much in the sequence. So everybody now know that China is into the market, BYD, and all of you even know that how Chinese people they work very hard with this algorithm part, even though they don't have much of hardware unit to be built in their places. There's Intel when we talk about the Intel systems and other things. With a lower version of hardware units, with a higher intelligence of software unit, they could build so many things. That is the beauty we have always seen. So BYD, just build your dream, is comparative. You can see the comparison between BYD and Tesla in terms of various features, and you can see that one or other way they are good. Okay, so one or other way they are good, and all of you do understand that, as I mentioned earlier, the BYD is something which used to manufacture only small batteries. In 2003 only, they have launched their first vehicle, a normal battery vehicle actually. But now things are different. They are slowly capturing the market. So let us see what will be our contributions when we write a research paper, and when we talk about various component optimization of various hardware units, developing hardware units, or optimizing our algorithms in terms of understanding or finding out, or writing it for a specific task. So that matters also. That also matters when we publish, and when people see it, and when people ask for that concept, actually implementation part. So that really matters. And furthermore, you can see that there's a choice of different bias actually. How do they, and it differs actually. Some go for Tesla, some for BYD. It all depends, and it is upon us actually. So BYD is best for affordability, battery safety is there, a rapid global expansion that everyone can see, and Tesla is best for the technology basically, and the autonomy, the charging infrastructure that it has, and the performance altogether. So with that, thank you everyone. But before ending up the session, I would like to show you uh, some of the. I would like to show the curriculum of the course that is being offered, and this is just to give you a rough idea about at an M.Tech level what we can learn. Actually, it's not just anybody to join as such here, but it is to just make you understand that these are the things that you need to basically study. I hope the curriculum is visible. Vinayak sir, is it visible? Yes. Okay. Now, okay, I'll just make little bigger as well. So So this is being initiated now only. It doesn't mean that it doesn't have any. We don't have that capability, or we don't have that infrastructure, or we don't have the sufficient faculty member. We have everything set, and based on after that only we have started this program. It's not just for the sake, but it's basically for research and development also. I'll come to that also. What aspects this program being a supported by industry, that also I'll talk about. So I'll just talk about few things. I mean, the syllabus actually. Uh, Other things go you can find out in the internet. In fact, so yeah, here is the content actually. Basically, Christ take it in a different form. I don't take it as like a bit of second of publicity and all, but whatever is being learned, it is in terms of two way. One is service, and it is famous for service and excellence. So whatever you are going to learn actually as part of the syllabus content, it is a practical oriented. So in theory, it won't be like complete theory. It's a practical oriented thing actually. So talking about, and at the same time, the research method, this is common. The research method IPR is a common paper for everybody in tech actually. But there are some audit cores also. I'll talk about that also. And but the major, you know, with all this knowledge, you have something which is known as holistic education that is also being added. It doesn't mean that kind of a religion and all those things. Not at all. Actually, it's about what is the best practice or the approach to understand something in a positive way, and to make use of the freedom of knowledge, and make use of it for the development of the country and the nation, even the world. So we have, as mentioned, we have the energy storage system. So it talks about obviously the storage unit where you're going to store your energy. It's all about the batteries and other things. Next, you can see it's about the motor and drives. So what are the different types of motors, drives, and And research definitely you can do in each of this. I mean, like a storage system, you talk about motor and drives, the different types, various different types for EVs. And in the syllabus, I'll just show you the syllabus also a little fast, and we talk about that. And so much to learn in this. And then power system, as we have seen, in there was a power system module also for the electric vehicle in the hybrid mode. And automotive electronics, that means it talks about all the components of an autonomous and automotive systems. And as you can see, there are two labs. One is energy storage system for this, and a smart grid uh, lab is also there. So how you can get an optimized energy from a grid unit, and how you can uh, pass it back also. It's not just taking the energy from the grid, but at the same time it's quite possible to give it back as well. And rest of the course it is very much already mentioned. Then we talk about the battery management system, BMS. Oh, okay. So talking about this, one thing, we have the center of excellence here, and that is something very unique. And in that, we have one of the company known as Decibel. And as you know, the Decibel is organizing this event. And in Decibel, you have so many things, so many. Uh, you have this battery management system which is very strong, and they have the latest art of technology systems to do a lot of research, and many are doing research for the past 2 years, actually 1.5 years, I think. And it is being students being trained, and all the lab components. Okay, the institution takes care of the lab component, at the same time ensures that the most standard uh, equipments which is in the market, actually the latest one, students could make use of it to do the research actually. So Decibel is something which helps. More to know about Decibel, you can definitely, we have the link there. You can in LinkedIn, you can check it. Actually, you could see various programs that is being organized by them. Not only that, there's so many things uh, to to learn from this uh, lab. Actually, it's a very big lab with a very big space in the center of excellence in the Christ University. And the next is the digital twinning. Everybody know what is it. It's something which is very interesting, virtual. And I had a visit to Singapore where I have with my friend. I could understand that everything. I mean, every corner of Singapore is monitored, well monitored. If you talk about the traffic, if you talk about the weather, if you talk about any movement of any person in Singapore, it's so virtually they can monitor. So much of research they can do by simulations, and through tuning they could easily track each and everything in Singapore. So that is something very amazing. Okay, so that is something you can learn actually. Next is the software-defined vehicle, which I already said. And the those who are they see, my core background is computer science. I past 1 year I'm doing my postdoc in electric vehicle technology only, with software-defined vehicles. So something different from a common domain, because computer science could be applicable to any field actually. So, and anyone who is working in any of the other domains like civil, mechanical, or electrical, they it is kind of mandate for them to understand what is the technology, or the models being used to control the different units. And when I say model, it's about the AI systems and computer science actually. So that we'll be learning. And as you can see in program elective, we have the EV thermal management. Okay, so obviously when we talk about battery management system, the thermal management is very important for the EV technology. You might have heard about, like somewhere something is blasting. So many things are there actually. So how to control those things, and that is being learned here actually. We have digital training lab, and the most important, I said, the battery management system lab is there. And then we do mini project audit course is there. and holistic education is as it is actually. The third semester is all about once you are defining your software for a vehicle, it is important that you verify and validate also, and that is a major concern. And moving forward, the functional safety standard is all about your is uh, all about your security actually, cyber security actually, security aspects, all the functional safety, and that standards need to be followed, and the external software security also plays into it. MOOC as is basically offered any relative course which is with respect to your computer science, which supports your EV technology, is can be chosen, and project phases will start in first and second phases. So altogether it is say 72 credits. Together it is basically 72 credits. So there are detail. This is a detailed course that you can see in the website also. I'm not going into that very much, but obviously just want to show one syllabus actually. The rest of the things we can refer from the say for example energy storage management system, and or you can suggest me some. I can open it directly from. So energy management system, you can see what all things we are going to study, and each and every uh, module we have an output, that our course output, the learning, but you can read here, that is from the modules. Okay. So supercapacitors and fuel cells, battery management system here, all the researches you will, and the emerging trends that is happening with the battery, that also being taught. And let us see what is there in the battery management system. Yeah, the events on chat term. It's here is the battery management system. You can see what exactly you're going to study here. So everything, which it is limitless actually, and if you can test each and everything here in this lab. So it's a state of art of equipments you have here, and I think it's all it is in my another system basically. Otherwise I would have shown you all the photos also, but you can definitely refer to Decibel Labs in LinkedIn, through which you can see what are the different equipments that we have. And in Christ also we have certain other uh, equipment. So one more thing I want to show was audit. With this I'll end my session, but I want you to see this also, audit course. So what do you mean by this audit course? An audit course is, as I said, it's not just about learning. You are going to learn each and every component of an electric vehicle. You're going to learn the hardware part as well as the software part, the different layers, protocols, and the architecture. Not only that, you will be learning some audit course, then how to do publication. I mean, how you are going to explore and learn something from the course, plus you're going to put it across in the world. I mean, so you have the research writing, you have entrepreneurship space, you have the publication tools, you have project management, and the most important thing for everybody is well-being and mental health. So this is a complete combination of everything to make you to the level in a competitive world in a best possible way. Okay. So this is a glimpse. Okay. So what I wanted to say, or what I want to deliver was, it's not about like as I said, it's not about the promotions or the not like that. It's about want to make you and make you understand what is the content of the course, and what you're going to learn as a whole actually, because when we say EV technology is a specific domain that we are talking about in M.Tech. Okay, so with this, I would like to wind up, and I would like to open it for a question and answer session. Over to Vinayak sir.
Yeah, sir. Thank you. It was an amazing session, sir.
Um,
Any questions? By the way, I have given the links, important links of the M.Tech course in the chat box. Anyone interested can find there.
Thank you, sir.
We are open to
You can put
questions.
that decibel, uh, that lab also, our Center of Excellence lab
Yes,
also.
sir. Yeah, photos folder is also there.
You
They
can
can
see.
explore those also.
Okay.
Yeah. Any questions? Actually, we have a question from Mr. It's a general question on SDV. Any questions on M.Tech course?
Okay, that is one question was there. SF, who is SF? Yeah, same achieved. What is software defined vehicles? I hope that I have explained it. Uh, or electronics need software. I want to know what makes SDV different from a normal embedded system. Rockets, rockets use software. Can we use software defined article? Yes, madam. Yes, madam, sir. Obviously, when we say software defined vehicle, not just vehicle actually. So when the concept of this Internet of Things came up, there were people who were talking about Internet of everything. It's not just Internet of Things, but it's about Internet of everything. So when I say Internet of Things, we are talking about all electronics equipments around us. So your tree is going to talk with you. The plant that you are growing, or anything around you, which is basically an object which is not living actually, is going to talk with you. That means you're going to embed chips with every small units around you. Okay, so your almirah is going to talk to you. Your table is going to talk to you. So it's not just about the your fridge or your fan and everything. Everything around you, which is non-living objects. Therefore, we would say an artificial intelligence. So we are going to make the artificial object intelligent. Actually. So they will be able to communicate with us. So far, they were able to predict things for us, but now we want that system, which is in the form of software, embedded in any of the applications, maybe say rocket science or anything. Uh, it is it is going to address you. It is going to address you the way you as a human being address your decisions, or your point of decisions, or your thought process to anybody else for any queries. So, if that is happening, what does it mean? It means that we are moving towards artificial general intelligence, which means that the system is going to be as capable as us, which is not true at present, because every system is because without our interface, system won't work in that level. But we are in that race. That's why I said it's a generative AI. We are in that race, so we system is able to generate things like us. Now we are moving towards, after artificial general intelligence, we are moving towards artificial super intelligence. That means beyond our capacity, our capability. We are moving. We have increased our computing power with quantum computing. We have we have all sort of optimized software writing methods. Okay, so one thing which we, as I already mentioned, is we have to be very careful is about the security system. Because if we make all these things, once these things are ready, and if the system hand over it to systems are intelligent to make the optimized algorithm or do computing in its way which is above us, then it becomes a artificial super intelligence. So we won't be having any control on this. I hope you got my answer. So using AI makes it software defined and it is intelligent. Uh, no, AI is something that AI is basically used to make the system intelligent, like us. So AI helps to make decision making. So decision making based on predictions. It does, as we do predict based on our knowledge. It does the prediction. So That way, if it is able to predict it rightly, say 99.9%, like we can predict whether it will rain or not. How do we predict whether it will rain or not? Obviously, looking outside, seeing the condition outside, clouds and everything, and then we could make a with our sense we could predict that, and it rains also. So like that, the system to understand that scenario, it needs all these attributes to understand and give a decision. So it's not just about the including AI into software becomes a software defined vehicle. No, not at all. It's not like that. You need a basic, as I've shown you the architecture, you need a basic layers to first control your hardware units. Okay, so to make your system, I mean, your electrical vehicle intelligent, that is the next part. That is the next level thing. For that, you have different inputs, and then you have the algorithms which makes use of these inputs to get an output and to make it intelligent like human being. That's all. When we say software defined vehicle means now the vehicle, obviously, as you were mentioning that all small, obviously any hardware units, obviously it has got some software into it. Some coding has been written at a microcontroller level. Okay, microprocessor level. It is being written actually. Now we are talking about the layer which is on top of all these things, which make intelligent decisions. I hope it makes sense.
Yes, sir. Any more questions?
You're free to ask any questions. I am open to it.
I think no more questions, sir.
Okay, sir.
I think no more questions, sir. Let's wind up.
Sure.
Okay. Thank you. Thank you everyone for joining in. Once again, all the information for the M.Tech course is again shared in the chat box. You can find the links. Anyway, anyhow, we'll be sending the all the details via email as well. Thank you. Thank you, Shiju sir, for taking out the time and addressing all the attendees.
Thank you. Thank you,
Thank you.
everybody.
Thank you.